Okay, so our next presenter is Emily Blackburn, who's a PhD student at the University of Sheffield.
Hi, yeah, I'm Emily. I'm from the University of Sheffield, which is in England, so I've travelled very, very far away. And on Monday with the hurricane, so that was lovely and fun. Yeah, so today I'm going to talk to you a little bit about how PFAS is a hazard for drinking water and give you a bit of a context of PFAS in the UK. Yeah, thank you. Yeah, and then I'm going to present the methods I use, so where I got the PFAS data from, and then give you some initial results, and then some future work. Drinking water acts as a human exposure route for PFAS. So PFAS is produced, and then it's used in a range of products, and through their use, and then through their waste. This leads to environmental contamination. So PFAS ends up in the air, in soils, and in water. And I'm specifically looking at surface water, so rivers and reservoirs. So in the UK, what we do is we generally monitor water quality for drinking water. And specifically looking at PFAS, what we do is we quantify 48 specific PFAS and record the sum. So here are some of the groups that we monitor for. And then we also have this tiered system. So tier 1 is less than 10 nanograms per litre, and that's considered like ideal. And then tier 2 is between 10 and 100 nanograms per litre, and this is where there's like some slight cause for concern, so they'll increase monitoring. And then tier 3 is anything above 100 nanograms per litre, and when it gets to that stage, they will blend water sources to reduce the concentration, and then in some extreme circumstances, they'll take the water system off the grid. So PFAS is a massive issue for water companies. Monitoring for PFAS is really expensive. 48 is a lot of PFAS to monitor, and because of this, high concentrations are really easily missed because they only really do like low sampling resolution. And when we're thinking about water treatment, the traditional methods are not very effective at removing PFAS. And then even considering the advanced treatments, which are costly and aren't implemented everywhere, they aren't as effective at removing short-chain PFAS. So what my project is doing is looking at improving the management of PFAS in surface water in the UK, and this is being done by trying to get an understanding of the relationships between PFAS and catchment characteristics. So I've been using PFAS data, so the sum of the 48, directly from water companies, and I'm sponsored by Southern Water all the way down here. And then I've also been using data from Le Mans Forever Pollution Project, and this is an open PFAS data source. So it has PFAS concentrations in a wide range of environmental media all over Europe. The issue is that they look at various PFAS, not necessarily 48, but most of it is PFOS and PFOA, unsurprisingly, because it's one of the most, they're both the most studied PFAS. So what I've done is kind of look at the sum of the 48, and then to include both data sets, look at the sum of PFOS and PFOA. So for data visualization and analysis, just been looking at ArcGIS for some general spatial analysis and then presenting maps. And paired with graphs, I've been looking at the distribution of PFAS in UK surface water. And then with these graphs as well, paired with some advanced statistical analysis, so principal component analysis and self-organising maps. I've been using them both to like uncover the relationships between PFAS and catchment characteristics. So here are some initial results. This is the distribution of the 48 PFAS in UK surface water. So here is the average, and then this is the standard deviation. So So what this shows is that the majority of surface water sites have average concentrations below 10 nanograms per litre of the sum 48 PFAS, so within tier 1. And while there's some higher concentrations in England and the south of Wales, none of these sites have average concentrations above the 100 nanograms per litre, so none of them are averaging at tier 3, so that's good. And then what I think is quite significant is that we aren't seeing high concentrations with low standard deviations. So there's no sites that have consistent high PFAS levels. What you can probably see from the graphs is there's an issue with the spread of the data. So there's like clearly areas that have been missed, which is kind of helped by looking at PFOS and PFOA as a sum. So this is what's printed here. And again, we're seeing that most of the sites have low average concentrations. We do see some quite high concentrations as well. If we have a little zoom in, we see some high average concentrations around Manchester and Birmingham, and they're two major cities after London in England. But again, when we look at the high average concentrations, you don't see low standard deviations, so there's no sites that are significantly, consistently high, so that's good. So when we're looking at spatial characteristics, so anything that doesn't change too much with time, we're not seeing any kind of clear relationship between average PFAS concentration and any soil chemistry measures. We are seeing that but when you look at distances to the nearest point sources, you generally do see high concentrations nearer to the point sources, which is not too surprising. However, you also see these low concentrations, so that's a bit of a question there. Also, when you plot standard deviation instead of average PFAS, we again see like high standard deviations of PFAS close to point sources, so there's lots of variation there. So for the initial statistical analysis I've looked at the PCA. I've not done the fancy graph with the arrows yet, but I have this correlation matrix, which is presenting some possible relationships with average PFAS concentration and different point source measures. So there's some, but showed better by this graph. So we're seeing a moderate positive correlation with the number of airports within 15 kilometers and a slight positive correlation with the number of waste sites within 15 kilometers. And then when we're considering negative correlation, there's some slight negative correlation with the type of waste site and then average slope and nearest waste site. And this graph also presents how the soil chemistry really didn't have any influence on average PFAS content. So as I showed earlier, there's a lot of variation of PFAS close to point sources. So to me, this meant that maybe PFAS point sources don't consistently output PFAS, or maybe the transport of PFAS from point sources to water bodies vary. And to look at the second point, what I did was look at the temporal relationships against PFAS, and specifically looking at the surface water sites that were within close proximity to these point sources. And you do see some high concentrations with low rainfall, but again, you see low concentrations at low rainfall. And when you look at the correlation matrix, it is a sad story. There is no relationships there. And that's looking at rainfall, temperature, and soil moisture. So some conclusions. Most of the UK surface water sites have very low concentrations. Most of them are within the tier 1, and none are averaging in the tier 3, which is really good. We're seeing some potential relationship between point sources and average PFAS concentration, and the airport, looking at airports and waste sites might be the most significant. And then initial temporal catchment characteristic data doesn't show any kind of relationship now. But as my supervisor said, a lot of these measures are quite simple, so there might be more complex or better hydrological methods to look at instead. So because I'm sponsored by Southern Water, water company in the UK, I'm going to have the opportunity to collect high resolution data from one of their catchments, and this will be done at like quite high resolution. I'm hoping it will be like hourly. So hopefully that will give us some more information. And then hopefully if we can find some of these relationships and have a better understanding of PFAS relationships, I'm hoping to build some kind of statistical based model for predicting PFAS risk in the UK. So yeah, that's my email. If you want to contact me, shout if you're in the UK. Thank you for listening.
We do have time for some questions. I'll go, Mike. I don't know. Okay.
Yeah, Emily, just a quick question. You said your regulatory limit was 100 nanograms per liter. Is that for those whole 48 ones combined? Is that how that works?
Yep.
Okay, great. Thanks.
Oh, just a second. It's not a question.
Hi, Emily. Thanks for your talk. I noticed that you said surface waters. Do you have a sense of what proportion are streams and rivers versus lakes and ponds?
Most of them are rivers.
Okay.
Yeah.
I have a potential suggestion
Yeah.
or an idea. If you can, so concentration I think is a little bit wonky in flowing systems because you have such differences in discharge. I wonder if you could identify any catchments of interest if you converted to either yield or load. So if you have any like gauged rivers that measure flow, you can multiply by flow and then integrate over like a time area, and then you can look at what the PFAS load is instead of concentration, and maybe that could give you some additional insight.
Yeah, I have actually already done that. I just haven't presented it here. It had some kind of the same relationships I showed in the graphs, but just one, there was less data because it was like estimated, and then yeah, it was kind of the same relationship.
Okay, interesting.
Yeah.
Any other questions? Pilza. Well, not Pilza, but behind you.
If the varied PFAS concentrations from the same region, sorry, just a second. Did you consider the same watershed if the varied PFAS concentration from the same region or from the same watershed? Sorry for that.
I really don't understand the question.
Okay. Mohammed, can you reframe your question, please?
Yes, please.
You said PFAS varied also from the same catchment? Did you consider the same watershed?
I wasn't really looking at catchments, I'm more looking at specific sites. It's like, yeah.
Okay, good enough. Thank you.
Sorry, a bit confused.
No, thank you very much.